In this video, we will cover dealing with algebraic equations that have an absolute value in them. When I ask the question, what does the absolute value sign do? The most common answer I get from students is that it makes the number positive. While this is not necessarily wrong, it's not the exact definition of absolute value. The problem is, if you don't consider the actual definition, you'll only get the question half right. This sounds cryptic, so let's look at an example and what I mean. Here's the actual definition of absolute value. It says that if what's inside the absolute value sign is greater than 0, then leave it be. But if what's inside is negative, take the negative of what's on the inside. Pretty much what they're saying here is that when you're dealing with the absolute value, you will always have two cases. Case 1, you assume that the inside is positive, and case 2, you assume that the inside is negative. The absolute value of x equals 5. Okay, to get rid of the absolute value sign, we must create two different cases, one which is positive and one which is negative. To show the positive case, we leave everything on the inside just the way it is. However, to show the negative case, we put everything inside the absolute value sign into parentheses, and this time we tag a negative on the outside of it. To solve for the positive case, we don't have to really do much. For the negative case though, we have to isolate x by putting the negative on the other side. So what I did here was I divided both sides by -1 or -1, and now we have two solutions. We have x equals 5 and x equals -5. Here we have the absolute value of 2x plus 10 equals 18. Again, to get rid of the absolute value sign, we must make two cases. The first one, we assume the inside is positive. The second one, we assume the inside is negative. Let's solve case 1 first. This is simply done by subtracting 10 from both sides. Then we divide by 2. Now let's look at case 2. Case 2, we assume the inside is negative. So by the definition of absolute value, we should take whatever's inside the absolute value sign, put it into parentheses, and attach a negative sign in front of it. Now we're ready to solve for x. We can't touch anything inside the parentheses until we deal with that negative sign. Remember, PEMDAS. Divide both sides by -1 to get rid of that negative sign. Now it's just business as usual. Subtract by 10, then divide by 2. Our final solutions are x equals 4 and x equals -14. Okay, let's look at the last one. At first, you might think you should create two cases immediately. However, you only need to create cases at the point of which you need to get rid of the absolute value sign. According to PEMDAS, we have a couple of other steps to do before we need to do that. So first, we'll subtract by 7, then we'll divide by 2. At this point, we have to address the absolute value sign. So now we have to create cases. Case 1, the positive case. Keep everything the same and solve for x. I divide both sides by -3, which cancels out the 3 in the numerator. It also leaves behind a negative sign. For case 2, I put everything that was inside the absolute value sign into parentheses, and then I attach a negative sign to the outside of it. Notice how on the left-hand side now, I have two minus signs. Guess what that creates? A positive sign. So that means the only thing we need to do now is divide by 3. So this results in 1/2.